Okay, tetrapods. Gnathostomes that have limbs, right? So I suspect for some of us, some relatively familiar territory that we're moving into now. It's kind of a nice way to round out the unit by talking about some familiar creatures. Maybe some of you even own a few tetrapods along the way. So it's one of the most significant events in vertebrate history. Fins of some of our lobe-finned friends have evolved now into limbs and feet with digits, the ability to move about quite readily. So what defines a tetrapod? The word tetra, right, and foot. So there are four limbs. Feet have digits. Kind of a rule of thumb, the term is five or approximately five, right? So five is kind of the rule of thumb, although it's frequently not exactly five, right? A neck for separate movement of head, that's important. That's going to play a big role in predation and avoiding predators. Fusion of pelvic girdle to the backbone. So uh, one of the reasons you're able to freely move about, and particularly one of the reasons you're able to stand upright and move about, is because your backbone is now fused to your pelvis. Absence of gills. There are some rare aquatic species that still have gills, but for the most part, these guys are lung breathers, right? And as we'll see in the skull, eventually, some of the bones of tetrapod ancestors migrated into the ears. And the ears are very advanced now, so they're very good, generally speaking, at detecting sound. Another trait that's important for predation and for avoiding predators. And for listening to biology lectures. So here's our Tiktaalik ancestor, this lobe-finned lungfish. It's got a nickname, fishapod. So it's a fish, but it's a tetrapod. Well, it's actually a highly transitional species. One of these excellent examples that you occasionally see in the fossil record of kind of transitioning from one group to another. So it has both fish and tetrapod characteristics. It's got fins, gills, lungs, and scales. Has ribs. That's interesting. You don't generally see ribs in a fish. Your ribs actually play a pretty big role in being able to breathe. It's got a neck and shoulders that is going to become important, right? The ability to move the head back and forth. And then we see basically the pattern of bones laid down that is followed in everything that follows. You see essentially a big bone, two small bones, and then lots of little bones, and then digits, right? That's the basic pattern of every tetrapod limb that has followed since. So here we can see the actual fossil. We can see the big bone, two bones, lots of little bones, and then digits, sort of pattern that's laid down. Every tetrapod basically has those homologous bones with the associated muscle structure, right? So there are the fish characteristics of scales being present, fins, and you do see still gills along with the lungs. But there's the classic tetrapod characteristics now, the neck, the ribs. This shouldn't say fin right there, we should say skeleton, flat skull. Remember, we need a skull to protect the cephalization, the brain, and the eyes on top of the skull. All right, so let's start with the primitive tetrapods. These guys showed up immediately after our fishapod. So in many ways, they still have some of the fishapod traits. They tend to be aquatic for much of their life cycle. However, they can also be terrestrial. In fact, this root word here means both. Same root word that you see showing up in if you can use both your hands, you're ambidextrous, right? So class Amphibia, about 6,150 known species, although sometimes that number goes down. A lot of amphibians, unfortunately, have been going extinct lately. 3 groups. Your Urodila, those are your salamanders. Uranura, that's your frogs. Frogs, by the way, include something called toads, which are essentially dry type of frogs. And this is interesting. This means without feet. So that's your Sicilians. That happens to be a Sicilian there. Look almost like snakes, but they're amphibians, right? So that's a case of reverse evolution. They've lost their limbs. Ooh, that's exciting. Look how far down the list we are. Salamanders, what kid doesn't like to hunt for and catch salamanders, right? So salamanders are amphibians that have tails. Many are aquatic, but some are also terrestrial. Seems like kids are always out hunting frogs too, at least in the old days. I don't know about now. But anyway, what is a frog? Well, they've lost their tail. They had a tail as a tadpole, but they've lost it as adults. Good jumpers, right? Powerful hind legs for locomotion. And frog, well, there, I already said that. So toads are, it's in quotes because that's an informal term. They're still considered frogs. They just have less slimy skin, more leathery. They're a little more adapted for life in the dry land. I always think of thick-doughed pizza, Sicilian pizza, Sicilians. So these are legless, nearly blind. Um, like the picture we saw, they look a lot like worms, don't they? And that's, as I said, a case of reverse evolution. It's a secondary adaptation. There's another apoda. Salamanders and frogs, pretty diverse group. Um, Frequently, the distinct coloration in a frog is a warning sign that it creates toxins, right? So there's kind of a couple different approaches to some of these creatures. They might be toxic to predators, in which case they are brightly colored to warn the predator, or they might be highly camouflaged because they want to adequately hide from the predator. So there's a frog, there's a salamander. All right, this is a big jump in evolution now. Amniotes. So these are tetrapods who have reproductive mechanisms to adapt to dry conditions. It's an egg now that doesn't require water. So the frogs, they still lay their eggs in the water, right? That's called amplexus. The female puts the eggs out in the water, the male grasps onto her and puts the sperm also out into the water as the eggs are coming out. And the hope, of course, is you have enough sperm, you have enough eggs, and they're bound to find each other, right? Whereas everything that's an amniote now, the egg is adapted to survive dry conditions. You're going to see a couple major groups here, what are called diapsids and synapsids. Your diapsids, so the root word two, look at the skull, and you'll see 2 holes behind the jaw on either side of the head in the skull. Those are called the temporal fenestra. Whereas a synapsid, the one hole is drawn together to be with the second to become a single whole. So the synapsids are characterized with one hole on either side of the skull. So your diapsids, that's your archosaurs, that's things like turtles, crocodiles. Turtles, that's a very ancient lineage, by the way. Crocodiles includes alligators, dinosaurs, birds. Birds came from dinosaurs. And then your leptosaurs, which is tuatara, lizards, and snakes. So the early synapsids were kind of transitional from the later reptiles. They still looked very reptile-like. Then they started becoming mammal-like, and then eventually the later synapsids gave rise to the mammals. So remember, rootwort and amphibians, they can make a living water and land. They have to get back to the water for reproduction, right? These guys now are the amniotes. So they have this specialized egg. These guys can survive on dry land. So we've got our diapsids that give rise to our, so this is a basal organism here, turtles, very ancient lineage. Crocodilians, so that includes crocodiles and alligators. Then we see our dinosaurs arrive on the scene. So it's interesting, crocodiles actually predate dinosaurs, right? And then we see the later dinosaurs, things that include T-Rex. It's interesting if you look at the T-Rex skeleton, it doesn't look a whole lot different actually than a chicken skeleton. That's kind of a weird thought. And that's because birds evolved from small dinosaurs, small versions of what looked like a T-Rex, right? You do see some really, really fascinating aquatic reptiles in there. These guys, they were some of the most enormous marine reptiles that ever plied the oceans. Some of them were probably incredibly frightening predators. These guys are fascinating. This is a pretty cool case of like convergent evolution. They look very much like porpoises and dolphins, which of course are mammals, right? And we've got our leptosaurs, that's our tuataras, our called squamates, that's your lizards and snakes. And your early synapsids looked pretty much like reptiles still, but as time progressed, the later synapsids developed derived traits that we now consider mammalian. Alright, so what makes an amniote? The major derived character is the amniotic egg. That contains specialized membranes now that protect the embryo. So one of the things you no doubt will do in an anatomy class would be to memorize all the membrane layers. I'm not going to ask you to do that here. The important feature, however, is what is common to eggs is nutrition, the embryo, of course, and then a surrounding series of protective membranes. If it's a terrestrial egg, then outside the albumin you're going to find a shell, of course. That's reptilian. Birds are reptiles, so of course birds exhibit that. If the egg develops inside, well, it's not going to secrete the shell, so the yolk sac develops into a structure that integrates with the maternal blood supply. We'll call that a placenta to feed the embryo. Reptiles, they are frequently found in homes as pets, right? A lot of people keep lizards and snakes and turtles. I've heard occasionally of people keeping crocodilians, alligators. I don't know if that's such a good idea, but and many of you have an alligator at home. Birds, very common pets, right? Tuataras, they're probably banned. I don't think you can import them. They're pretty rare. Their ecosystem is pretty restricted. And of course, all the dinosaurs, all the extinct groups, right? So the scaly skin that creates a tightly waterproof barrier. The eggs themselves are waterproof, good for making a living on land, both those things. That means they soon outcompeted the amphibians on land due to these watertight adaptations, the skin and the eggs. Because of the fact that reptilia are diapsids and mammalia are synapsids, they're actually sister groups. Always fascinates me. Animals, right? They can be born or they can hatch. And they know what to do right away. How about these turtles, right? They hatch on the beach and they somehow know they better start running to the ocean, right? Incredible. Ectothermic. So most relatives, uh, the term is cold-blooded. That's not actually a great term. What it means is if you're ectothermic, you have to absorb external heat. So frequently you'll see a snake or a lizard basking on a rock in the sun to get its warmth. Birds, however, and it's postulated therefore dinosaurs, because birds are the descendants of dinosaurs, are actually endothermic, which loosely speaking the term is warm-blooded, not such a great term, but what endothermic means is you maintain a constant internal body temperature, right? Mammals are famous for being endotherms. So your surviving lineage of lepidosaurs are your squamates, and that's the term for a group that includes both lizards and snakes. Tuataras are lizard-like. As I mentioned, you, I hope, don't have one as a pet. They're probably restricted for importing. They just live actually in a very small location. They're restricted on some small islands around New Zealand. So it's interesting about the squamates, the lizards and the snakes. That group is actually the most numerous and diverse of all reptiles if you exclude birds from the reptile equation. So technically speaking, then, snakes are legless leptidosaurs, which have evolved from lizards. If you dissect a snake and look at its skeleton, you can actually see vestigial structures in there of bones that once would have been limbs. Snakes are carnivores, so they have certain adaptations for being able to capture and consume their prey. They actually have chemical sensors. They're very good at locating prey without having to directly see them. Heat detecting organs, basically that means they can see in infrared, like night vision goggles. Have you ever looked through or at least seen pictures of what it looks like to look through a night vision goggle, right? You're seeing the heat signature of objects and people. So snakes can see in basically infrared. Venom, that of course is going to paralyze the prey, so they don't have to keep chasing it down. And what's really cool about certain snakes is they have very loosely articulated jaw bones. They can open up wider, much wider in many cases than the diameter of their body, right? They have really stretchy skin. The word elastic means it can stretch out and then come back to its shape again. So snakes, some of them are famous for being able to swallow prey that are far larger than they are. Remember the word archo, archaeology, Archeans, original, ancient, right? So your archosaurs, your basal reptiles are your turtles. Crocodilians, very ancient organisms. That's your alligators and crocodiles. Certain pterosaurs, that's like a pterodactyl, for example. There's the word for wing again. So those are flying reptiles. And then, of course, your dinosaurs. So the crocodilians actually predate many dinosaur lineages. They go all the way back to the late Triassic. Still with us to this day, right? They're generally found in warm regions. Go to Florida, you got alligators all over the place. We all know what a turtle is. You might have them in your yard. You might have them as pets, right? So they have a box-like shell, and the shell is both an upper and a lower shield, and it's actually fused to their skeleton. So it's part of the vertebrae. Clavicles, that's your neck bones and ribs. So you've seen alligators, maybe in person or in pictures, I'm sure. Turtles, of course, snakes, all kinds of snakes. So here is the tuatara. And you see they're very reptile-like, but they're famous for having this incredibly restricted range, just a few islands that they exist on. This guy's interesting. Australia is famous for all kinds of weird creatures. So I mentioned T-Rex. Uh, these are called Saurischian dinosaurs. So T-Rex is quite large, but there were also very small versions, which were carnivorous. They were called theropods. So birds are actually direct descendants from theropods. And we don't, of course, really know what an actual living dinosaur looked like. I mean, we can reconstruct them based on their bones, but what kind of coloration to the skin, or did they actually have feathers? And some of them are thought to maybe have been feathered, actually. And certainly, since birds are directly descended from the theropods, maybe some of these theropods were feathered. And, there could be any number of reasons for that. Feathers make good insulation. They're colored in many ways, so they could be colored like the environment for camouflage. We see amongst birds now, they use feathers for courtship display, like a peacock, right? So by about 160 million years ago, these feathered theropods were pretty much what you'd call a bird at that point. There's that word archae again, and the word wings, right? The ancient winged one. So that's not to say it's the original bird, it's just the oldest bird fossil that's yet been discovered. But it is a very transitional fossil example. It still has some of the ancestral features that you'd find in a theropod, like teeth, for example. Look in a modern bird at its beak, you don't find teeth in the beak, right? Similar wing structures and flight ability to modern birds based on anatomical analysis. However, it's been established that you've all seen birds, right? You've watched a bird out in the yard, and something comes in and it just takes off, right? It just takes off from standing. Well, apparently these guys were pretty good at flying, but they had to launch themselves off of a height, like a cliff face or a tree or something like that. They apparently couldn't just take off from standing. Part of the reason for that is they still had what looked almost like a reptilian tail, right? And here you can see they do have a beak, but there's still teeth in there. So its face looks kind of like a reptile. It's got a reptilian tail, claws on the wings, but what's cool is their wings are modern bird wings. Airfoil that's shaped like an airplane wing, right? So airplane wings are shaped the way they are to create lift. So they're basically airfoil wings with contoured feathers, just like a modern bird. So they're apparently very efficient flyers once they were able to launch into the air. So no surprise the derived traits of birds relate to adaptation for flight. So they've got contoured airfoils, they've got wings with feathers. The feathers are made out of the same stuff your hair and nails. That's a protein called keratin. Lots of times people say, hey, look, the bird pooped on my car, or, you know, what have you, but you're actually not looking at poop, you're looking at the urine. And the reason for that, they don't have a urinary bladder, so what they do is they excrete urea waste products, but they excrete them in a solid manner. And the reason for that, of course, is they don't want to be weighted down with excess liquid, right? The heavier you are, the harder it's going to be to fly. So some really interesting adaptations to save weight. The females only have one ovary, reduced size to the gonads. The bones are actually hollow, and teeth weigh a lot too, so there's no teeth in the beaks. So I've seen plenty of bald eagles in pictures and zoos and stuff, but it wasn't until not too long ago I was driving home from West Campus, and you know how West Campus is along the river there. Eagles are famous for being associated with rivers, and driving down Industrial Highway in Pottstown, and all of a sudden a bald eagle just swooped right over my van and went flying off towards the river. And I was like, holy cow, it's the first time I've seen one in person like that. So you see the feathers, right? And you see the fact that the bones are hollow. That's actually a very strong hollow columns there. Try a little trick sometime to prove to yourself that that's a very strong feature. Take a piece of paper which is kind of flimsy, right? Roll it up in a column, tape it so it stays as a column, and you can actually put a heavy book on there and support the weight of a book. So we talked about snakes and lizards as being very diverse reptiles aside from birds. Technically, birds are in the class reptiles, reptilia, right? So birds very diverse, and you know that. But here's some interesting bird pictures. We associate birds with flight. They can be flightless. That's a case of reverse evolution. Or they can actually use their wings for being very efficient swimmers. Kind of fun to go to the zoo and watch penguins. They're very athletic in the water. So I mentioned going up to Vermont before. We see a lot of hummingbirds up there. And I was just talking to my dad on the phone the other day and happened to mention to him that I've never seen a hummingbird in my own yard. And guess what I saw today? Isn't that weird? What a coincidence. I saw this beautiful hummingbird come flying to these zinnias that I mentioned before that they attract the monarchs. Well, apparently the hummingbirds like them too, and I never knew that. So my first hummingbird in my very own yard just now. Isn't that cool? I know this lady who is obsessed with flamingos for some reason. My mom's actually obsessed with penguins. I guess everybody has their thing. So here's a flamingo. The pink apparently comes from pigments in the shrimp they eat. So if you see a really pink flamingo at, say, a zoo, they're actually feeding it food that is highly colorized so that their feathers look really pink. Cute little chickadee, very common type of bird around here. I used to be a dinosaur? Are you kidding me? All right, getting close. Lots of slides, but like I said, many of the slides were simply pictures. So that's the end of part A.